Hi everyone. So today we are going to discuss a brand new topic which is chapter 5. Alright, so in chapter 5 the topic given is progressions. There are some keywords that you have to take note in this topic. Number 1, sequence. Number 2, arithmetic progression, common difference, geometric progression, common ratio, sum to infinity, and recurring decimal. Actually, there are two subtopics in this chapter, whereby we have arithmetic progression, whereby I will be using AP for short, and then we have geometric progression, whereby I'll be using GP for short. Alright, so the first part that we have to discuss today is how do we identify if a given sequence is an arithmetic progression. Sequence that has common difference D is known as arithmetic progression. So we will see what is meant by that statement. Let's say we have a sequence 1, 3, 5, 7, 9, and so forth. Let's say this is the first term of this sequence where I denote it as T1, and this is the second term. I denoted it by T2, the third term T3, the fourth term T4, and the fifth term T5. So in order to identify is this sequence an arithmetic progression, then we have to check the difference of two subsequent terms. Okay, so let's check the first one. So the first subsequent term here will be term 1 and term 2. So when we look at term 1 and term 2, the difference between the second term and the first term is actually 3 minus 1, which is equivalent to 2. Now let us proceed to the next one, the second and the third term. So the value of the third term here is 5. The value of the second term is 3. So 5 minus 3 is again equals to 2. Go to the next pair. We have T3 and T4. So T4 is equivalent to 7. 7 minus by 5 is again equals to 2. And we'll go to the last one, which is the fourth and the fifth term. So the fifth term is 9, whereby 9 minus 7 is equivalent to 2. So when we observe the difference of the two consequences term are all the same. Hence, we can draw a conclusion that this sequence is actually an arithmetic progression. Alright, let us look at the first example. Determine whether each of the following sequence is an arithmetic progression. Give your justification. Alright, we'll look at the first one. So we will compare the difference between the first pair of two consequences term here, whereby we have 350 minus 358, then we get a negative 8 here. Find the difference of the second pair of two consequences term. We get 342 minus 350, which is also equivalent to negative 8. So when we look at the difference, it's the same. So this is an arithmetic progression because the difference are the same. So that is actually the justification. So let us look at the second example. So what do? we take the first two terms of the sequence, find the difference, we obtain 4 over 3. Second pair, we obtain 4 over 3 as well. And the third pair, we obtain 5 over 3. So when you look at the common difference, they are not the same. Thus, this sequence is not an arithmetic progression due to this reason. Let us look at the next example. An auditorium has 15 chairs in the first row, 19 chairs in the second, 23 chairs in the third, and so on. Determine whether the arrangement of chairs in each row follows an arithmetic progression. Again, give your justification. So the very first step here is actually to write down the sequence so that we can see clearly. This is the term 1, this is term 2, and this is term 3. So in order to determine whether it is an arithmetic progression, we will find the common difference. So between 19 and 15, the difference is 4. 19 and 23, the difference is again 4. So the conclusion, it is an arithmetic progression because it has a fixed constant 4 as the common difference. Okay, after we identify whether a given sequence is an arithmetic progression or not and give justification to our answer, the next thing that we have to do is to derive the formula of the nth term of an arithmetic progression. Let's say we are given a progression that starts with 2, 5, 8, 11, and 14. And this sequence is an arithmetic progression. So what are we supposed to do right now is we need to identify that this is T1, this is T2, this is T3, this is T4, T5, and so on. Alright, we have discussed earlier that we will be able to find the difference, the common difference of this arithmetic progression, whereby we take the value of the second term minus by the value of the first term, whereby we have 2 minus by 5, which is equivalent to 3. In an arithmetic progression, the first term is also known as A. So let us check. So the first term here, T1, is equals to 2, whereby this 2 is actually the A. Alright, so the second term here is 5. So 5 is actually 2 plus 3, whereby the 2 is the value of the first term, and the 3 is the value of the common difference. Look at the third term here. The third term, we have an 8. So how do we obtain an 8? Actually, 8 is this 5 plus another 3. So this 5 is actually A plus D. 2 plus 3 plus 3. What about the fourth term? 11 here. T4 is actually A plus D plus D plus another D. Let us illustrate further. 2, 5, 8, 11, 14. So we have to plus 3 here, plus 3 again, plus 3 again, plus 3 again. Alright, so 2 plus 3. 2 plus 3, we will obtain 5. 2 plus 3 plus 3, we will obtain an 8. 2 plus 3 plus 3 plus 3 will get 11, and 2 plus 3 plus 3 plus 3 plus 3, we will actually get 14. So you can see the number of D involved here. Alright, so when we look at the first one here, it has 1D. The second one here, 2D. And the third one here is actually 3Ds. Alright, so actually you can determine if the T5 is here, how many D we will have at the end here. Yes, you are right. We have 4 Ds. Alright, so when we write this in a formula, alright, in a formula, we will get, the first one is A plus 0D, because it doesn't have any D here. The second one, A plus 1D. As you see, there is only 1D here. Alright, I'll highlight all the A's. And then the third one you see, there are 2 D's here. So 2 D's here. And the fourth one is actually T4, which is A plus, yes, 3D. T5 is A plus 4D. Alright, so by deduction method, we can look at this formula here, whereby this one remains the same. Okay, so that means in our formula, the A, it's always there. So when you look at this part over here, T1, T2, T3, T4, T5, that is a variable, alright, whereby the value keep on changing. So if I substitute this by an n, I shall get a Tn here. So when we look at the relationship between this one and this one, and also this one and this one, okay, and also this one with this one, what can you see? Let us make it clearer. Okay, so we'll see here 1, 2, 3, and the other side will be 0, 1, D, 2, 3, and 4. So what can you observe from there? Yes, it's actually n minus 1, whereby 0 is actually 1 minus 1. 1 is actually 2 minus 1. 2 is actually 3 minus 1. Thus, we have a n minus 1 times D here. This is the formula of the nth term of an arithmetic progression. Alright, after we derive this formula, let us make use of the formula. Look at example 3. Find the 15th term, which is T15, for an arithmetic progression here. Alright, so when we look at the questions, it's very obvious that some of the values are already given. First of all, that is the formula, okay, whereby this formula comes from Tn A plus n minus 1 times D. So we already know that the n is equals to 15. So this n here we substitute by 15, as well as this n over here. Alright, so the next step will be identifying the value of A. A is always the first term of the progression. The second one, to find the common difference, whereby we have a T2 minus T1 here. So we get a 6. Substituting it into the formula, compute the answer, and we shall get T15 equals to 80. Let us look at the second question. Find the 24th term. So what is 24th term? Yes, exactly. This is T24. So by using the same formula, T24 is equals to A plus 24 minus 1D. Substituting the value of A, which is equals to negative 6, and D, which is equals to 11. Perform the calculation. The answer is 247. Alright, let us look at example 4 here. Given that an arithmetic progression with the first term negative 6 and the common difference 11 and the nth term is 126, find the value of n. So first of all, the A is given, negative 6 in the question. D, it's also given. And Tn is equals to 126. By substituting everything into the formula, we will get 126 equals to negative 6 plus n minus 1 times 11. In order to find n, we have to perform this calculation first, whereby we have 126 plus 6, and then the value will be divided by 11. So 12 is equals to n minus 1, and thus n is equals to 13. And the last example for today, Siti wants to arrange books at the front section. She arranges the book by stacking them with the first book at 2 cm thickness at the bottom. However, the subsequent books have the same thickness, which is 1.5 cm. Find the total thickness of the book if she arranged 16 books. Okay, that means we have book 1, book 2, book 3 until book 16. So what are we looking for in questions A? Yes, we are looking for T16. So T16 will be A plus 15D. Okay, A plus 15D. So in this case here, the A is 2 and the D is 1.5. So the total height will be 24.5 cm. The second question, number of books. Okay, so that means it's being arranged until end. So the thickness is actually 30.5. Okay, so this thickness is referring to Tn. So Tn is equals to A plus n minus 1D. Alright, so this is the A, this is the D. Again, we have to perform this calculation first, whereby we have 30.5 minus by 2, and the answer will be divided by 1.5. Alright, in order to find the n, we have to plus 1 to 19. So the final answer is 20. So after we have actually discussed example 1 until example 5, you will be able to answer exercise in 5.1 as well as 5.2. We will discuss these questions in our next lesson. That's all for today. Bye.